The GTE spec cars in the last 10 years, they got 10 seconds faster on a 2-minute 20, 2-minute 15 lap. So 10 seconds is a big amount, but the engine power was kept quite similar. So this improvement of 10 seconds has to come from somewhere.
On today's episode, we are talking to Arne Peeters, who is a race engineer for Proton Competition, a Porsche customer racing team running in the high-level racing series. So for those who don't know, it's Tim and Andre here from High Performance Academy. And the topic we're really getting into today is all about a pretty in-depth discussion about some of the differences between GTE, GT3 racing, really what's under the skin in one of those cars. That's something you hear a lot of people talking about. GT3 is a pretty famous sort of sports car series these days. A lot of people know about it, but these things are actually probably, while they're sort of treated as maybe somewhat of a boring customer car in some ways, there's actually a lot going on under the skin of one of these things.
Yeah, I think on face value, you look at this and then you just pull out your checkbook and write a big old check and go racing. And while absolutely you can do that, the ability to tune these cars and actually optimize their performance on track is just like any race car. There's a lot going on there. And to get the most out of the car really does require an in-depth level of knowledge as well, which is really interesting to find out about.
Yeah, for sure. And like anything else, as time has gone on, these GT3 and GTE cars have become pretty sophisticated. There's Definitely a lot of tools that have filtered down from high-level race series, whether it's electronics, whether it's really sophisticated aerodynamics. So it's a lot of detail that's going into tuning one of these things.
I think for me, one of the interesting aspects as well, which I still haven't really got my head around, is between the GT3 and the GTE. The GTE variant is the faster of the two. Yet the GTE comes with no ABS, and the GT3 cars do. Do you know what that's all about, Tim?
Generally, the way it's split is GTE is all pro,
sure,
normally, and GT3 is designed as a customer racing series. So this is where you get
gentleman races.
The wealthy guy that wants to go racing, he needs a bit more support. If you were to throw one of those guys in a GTE car, it's a bit more of an overwhelming challenge. In saying that, if you go somewhere like Le Mans, currently anyway, there's no GT3 racing there. There's a Pro-Am combination, so the gentlemen do have to deal with it in some cases. And in the case of Arne's situation, they're dealing with customer racing with GTE in some series. So, that's probably a pretty impressive hurdle for some of those guys that aren't professionals that are able to deal with those big, scary fast cars with no ABS.
Definitely. And I mean, I think the other thing is these aren't sprint races. We're talking sometimes 24-hour like Le Mans. Endurance races. So these are long stints, and keeping that concentration and keeping the car on that braking threshold consistently, corner after corner, lap after lap, that's no mean feat.
Absolutely. And remember, in endurance racing, your tires have got to last more than one stint.
Yeah, definitely.
So you go and you don't have enough tires to do the whole race if you start flat spotting them. Yeah. So there's a lot of pressure there.
Yeah, so it's not just about going as fast as possible. It's actually about looking after the tyres and looking at the long game.
Absolutely. Yeah, on that, there was a Instagram post that we put out recently actually on the topic of ABS. I find it's always one of those things that a lot of people love to stick the boot in when you say, I've got ABS in my race car, or what does this knob do here that controls, that's the different ABS setting. A lot of people like to say, oh, that's not real driving.
It's always a hotly debated topic when we talk about ABS or paddle shifted gearboxes, and there's always those who are going to jump up in arms and say that, it takes away from the skill of the race driver. Yeah, we're not arguing that.
Absolutely. And the post in particular was just essentially talking through, there's like an adjustment knob that essentially every car that has a motorsport style ABS system has, where you can tune the level of intervention that comes in with the ABS. And that's normal from both, whether it's different weather conditions, whether you've got different tires fitted, you might have a wet, you might have a slick, you might have an intermediate option, whether it's the level of tire degradation that you've got, how much grip, how much aero grip you've got, all of that stuff. And I think it's very easy for people that aren't running a race car and maybe a relatively, to some decent level, to appreciate how difficult it is to drive one of these things and get the most out of it. And, I am absolutely a believer that there's no shame in using ABS on a car. Like, it's really hard.
Yeah. Look, I'll put my hand up and say we rely heavily on ABS in our Toyota 86, and I'm not ashamed to admit that. Yeah, definitely there's an aspect of driver skill that comes with a non-ABS car. And I think the other aspect that's really important to understand there is these motorsport ABS systems dramatically different to the ABS system that we're likely to find in our road car. And quite often, depending on the tuning of the road car ABS, we actually find that get that on a racetrack and you can actually end up slowing down quicker if you actually stay away from that ABS sort of manipulation or interjection, if you like.
Yeah, absolutely. That's a really good point. The big difference between a motorsport ABS and a road car ABS, and this is something you've experienced with one of your race cars as well, is that there's a big difference in even road car ABS from one car to another.
Yeah.
Some road car ABS are absolutely terrible, and the best thing you can do is pull the big fuse out and stop it working.
Definitely.
Whereas, GT86, something you run quite a lot, you actually find that quite useful, even with the completely stock factory calibration.
Yeah. It's definitely, you can't sort of paint them all with the same brush and say that they're all good or all bad. It's a case of experimenting and seeing how it works. And on that note as well, for those who are listening who maybe are interested in learning a little bit more about race driving, improving your performance out on the racetrack, and we do dive a lot into braking technique as well as ABS systems in this course. We've got our race driving fundamentals course that is available. And for listening to this podcast, you can also use the coupon code podcast75, and that will get you $75 off the purchase of your first HPA course. And we'll put a link in the description there for that course. All right, Tim, shall we get into this interview?
Yeah, let's do it. So today on the podcast, we have Arne Peeters, who is a data, performance, and race engineer for Proton competition across the World Endurance Championship, the European Le Mans Series, IMSA, and other championships as well. Welcome to the show, Arne.
Hi, Tim. Nice to be here. Good introduction. My name is Arne Peeters. I'm a Belgian guy living in Germany at the moment. And since this year, I'm a full-time race engineer for a Proton competition in both the World Endurance Championship, the European Le Mans Series, and I help out as a performance engineer and strategy support in the IMSA Series, mainly the racing only in the US and normally Canada, but because of COVID, all races in Canada are cancelled. So it has been a busy year. And on top of this, I'm doing now a podcast.
Can you give us a bit of background? Like what degree did you do? What was your sort of path to becoming all these different types of engineer we're going to talk about today?
So actually my experience was quite limited. I got mainly interested in cars, but mainly technology when I was doing my master's degree at the university in Leuven. It's a city in Belgium. Actually, I'm a mechatronic electromechanical engineer, so sensors and all this kind of stuff and controllers. But I started with the first electric Formula student team in Belgium, and I got very interested in tires, simulation, vehicle dynamics, everything around, and how to use simulation and estimations and calculations to make the car as fast as possible without being on the track. And also my master thesis was going about this. So I made a whole vehicle simulation model and a tire model based on all the data I was able to find. I was the only guy mainly interested on this topic on the entire team. So they were always wondering, what is he doing behind his computer? And he's always looking at the same screen. So it was a bit of a, not easy time to convince them. But then 3 years later, when I was already gone for 2 years, I got a lot of messages and emails because they had questions regarding vehicle dynamics and setup and how to do this. But then I was gone already, so it was not really easy. I just gave them my thesis, and that was it. But then after this, I went to Ford Motor Company in Belgium as a development engineer for vehicle dynamics for the bigger vans, so 2.7 till 5 tons cars, and also as a tire development engineer. So also driving my own tires, tuning the bump stops, tuning the damping, tuning even the engine support mounts to make sure if there's an effect on the vehicle dynamics or not. And after 1.5 years, I moved to the US to Optimum G. And I became the very inexperienced colleague of a certain Tim White, who's sitting there as well in the podcast. And I was working for Optimum G for about, I think, 3 years. And in this time, I got more involved into racing. simulation, racing, engineering support, be on track itself. And then I got involved also in Dunlop Motorsport. They put me in the team of Proton competition for the World Endurance Championship and Le Mans. But then they changed to Michelin tires. So they asked me, can you come directly to us as a support engineer? So then I did the next year working for them in all race series, both WEC and the DLMS. And then when I left Proton, I went directly to Proton competition as an employee. And I'm still there.
Can we just go back a little bit? You mentioned Optimum G, and as you alluded to, I think that's where you and Tim met. Tim was working there as well. Can you just give us a quick rundown on what Optimum G is and what's taught there?
Optimum G, they do mainly three things. They build seminars, they give seminars regarding vehicle dynamics and data acquisition and how to use the data on track or in simulations. They also they also develop software, so basic software to look into tire modeling, to look into the kinematics of the suspension, to look into the first steps of vehicle dynamics. The third thing they do is they provide also engineering support regarding KNC rigs, regarding tire modeling on a flat machine. They also do on-track testing, like sinus tests or step steer testing or brake testing. And also they provide support for racing teams regarding as a performance engineer or a data engineer, for example. Or we also had two guys doing the race engineering in the Brazilian stock car. And that's the main three things they do. And it's run by an old Belgian guy around mid-60s. And he's still doing it at the moment.
Before we get into discussing maybe the motorsport stuff in detail, I just wanted to pick up on your experience from the OEM world there as well. Like, how much, obviously you spent quite a long time working for Ford and developing, I'm sure, lots of different types of vehicles. How much link do you see there between what you learned developing road cars and motorsport? Do you think there's much there, or is it really separate?
No, it's a bit linked, I think, because at Ford it was more nice because I was the guy driving the tires myself. So if the tire was not good, I had the arguments from my side because I was driving the tires myself. To say to Bridgestone, to Continental, to Goodyear, to this doesn't work, or it's very aggressive, or the rear is stepping out, or when there's too much load, or the pressure is too high, or in the snow, or in the wet, the tire is not good, or there's no good feedback. While on the other side, so from Goodyear, Michelin side, you always have a driver. He gives his feedback to the engineer, and the engineer is having a discussion with me. So he always has to rely on the feedback he gets from the engineer. So this was much nicer in the OEM side because I was driving the cars myself, tuning and the tires as well. This is not possible in the racing. So this is very, very sad. But it's logical. But in the OEM, I would say they also focus a lot on small details. Like even we have two different engine mountings on the computer simulations. The difference is maybe just a few %, but this can be quite a big step on a passenger van, for example. And also we focus so much on small details we can feel as the development guys from the team, but in the real world, my mom, my grandfather, my sister, they will never feel this. But we're still like looking to find like 1 or 2% better steering on center, off center to make sure it's okay. But 99.999% of the people will never feel this. So it's both quite detailed, but in the racing, it's more nice because you work on a short basis. You have one race week, you have 3 sessions or 2 sessions, and the result you have already within the week. So after the race, while working on OEM, you work on a project it was 2014, and the project was finishing 2020. So the chances you get the end result, to see the end result, it's quite difficult. So this is the main thing I like with the racing, and also the biggest difference. It's you have the same technology, you have cars. It's a bit more complicated on the racing side, but it's going fast, and you get immediately the result what you try to achieve. And it's also better to learn faster because in 1 week you go from which tires do you use, what's the setup of the car, is there an issue with the engine, which gear ratios do you want to use, and you go from track to track to track. So every week you learn something new, and always if you think it's going to be the perfect weekend, always something is happening. so which you're not prepared for, of course. But then it's going faster. So this is the biggest difference between OEM and racing. It's faster. It's also more into detail. And I'm not allowed to drive the cars. That's the biggest difference.
So as far as your roles that you've got there at Proton, could you just give us maybe a brief sort of 1-minute description of each one of those roles, maybe some of the main differences, just for people that maybe aren't as familiar with an engineering structure in a race team?
Yeah, so we have a team manager responsible for the 2 cars, or 5 cars we have now in Le Mans, so it depends. But then you have a race engineer or a car engineer, we more call it, and he's responsible for the communication between maybe the chief engineer who is overviewing the both cars on the technical part, the technical director, the drivers, and the mechanics. Then you have a data, or for us, performance data / engineer, and he's responsible for making sure the data is downloaded from the car, the data looks okay, does it see something different in the data, how much fuel do we need to take the next stop, do we need to take fuel, yes or no, how many seconds do we have to fuel, also making sure the video, we have an onboard video, if it's working, if it's on the server available for the drivers to check. And then in every session, everybody has his own responsibilities, and I try to focus mainly on just the running of the car. But also, because I said it's a small team, so it's not like in a factory team. We don't have 5 engineers for each car. I'm also checking the data myself. I'm also checking, even if the internet drops and nobody knows how it works, I also have to do this. So just to making everything running in the team itself.
Yeah, so it sounds like you're wearing a fair few hats there.
Let's not forget about the hospitality as well. You're out the back cooking up dinner as well.
I'm always going one day earlier with a few other guys, and we build up the hospitality. So it's a big truck with a big kitchen inside. Then you put the floor, the tent, the tables, the kitchen, everything. And then we also have a second trailer. We call it the Corona trailer, which is a big trailer where the drivers can change, and there's some few office spaces. We call it the Corona trailer because it's the one we bought last year, just to get more space, because you need to have 1.5 meters in between officially. This is also something we have to build up. So I'm always the first there, I think, and the last one to leave.
So could you give us, across some of the different championships you're working on, so you'll be running, certainly in WEC, ELMS, and IMSA, these are all GTE or GTLM, what you call them in some classes. But I think you guys are also running at the Nordschleife with the 6 and 24-hour races there, which is GT3 based cars. So could you give us a bit of a high level sort of difference, a description of what a GTE car is versus what a GT3 car is?
Yeah, Proton at the moment, we only run GTE or GTLM cars. The last years I did the 24-hour races with a different team, Falcon Motorsport, and this was with a GT3. So Proton at the moment never run a GT3 at the moment. But the biggest difference is the price. I think it's almost double the price of a GTE, GTLM car. And it's the whole systems around. So it's a different engine, different gearbox. The aerodynamics is completely different, and also the amount of systems is different. In a GTE, GTLM car, you don't have ABS, but you have more options for traction control, the amount, the amplitude, it's interacting, the delay, it's interacting. The steering wheel is much more complex. Now in the car we have now, it's every 2-3 years there's a new GTE spec available from Porsche, and we have now the latest one, the 2019 it's called, and it's a big improvement regarding steering wheel. We also have multi-settings now. We can turn off the TPMS alarm, we can reset the reference lap time. If there's an error popping up, it's like in Formula 1 style. They call for Bravo 11 activated or Alpha 4 active, Charlie 7 deactivate. So there's a lot of possibilities now. And the biggest difference is with this new car, it's the aerodynamics. So the aerodynamics is quite, you can say as a GTE car is a GT3 car, but just maybe like on steroids. So it's a bit bigger, it's a bit faster, it's a bit more aerodynamics. The power is probably a tiny bit less than a GT3, but it's compensating quite a lot with the aerodynamics. For example, on a track here in Austria, the Red Bull Ring, last year we were testing a GTE car, a GT3 car, and a GT3 car was actually faster there because it's mainly braking, accelerating, and then just two corners which are aerodynamics. So then the GT3 car was actually faster there because the top speed was much higher, but the aerodynamics of the car was not playing a big role there.
You said the GTE actually is slightly lower in power, but in general, you've just given us that example of the Red Bull Ring where the GT3 car did actually happen to be faster in lap time. But in general, GTE is a faster class of car. So are they getting that just in terms of the change in aerodynamics you mentioned? Are they going to a lower drag, lower downforce aero package on the GTE compared to GT3? Is that what I'm sort of picking up there?
No, it's the car is also it's more heavy as well, but the aerodynamics is completely different. So you have much more downforce. So normally in the like Eau Rouge in Spa, everybody knows Eau Rouge in Spa or La Radion. There you can go flat with the GTE, but you cannot go flat with the GT3 because you don't have the downforce. But they have much more. They have maybe like 50 or 100 horsepower more. I don't know exactly. So they're just better out of the corner. So a very like in Monza, for example, it's also very stop go, and only one aerodynamics corner. So this is quite a big difference between the two cars. But also the amount of technology and the issues, electronic issues you can have with the GTE car, it's bigger. But I would say the biggest difference for me is still the price. It's quite big. So I think when the LMDH, so the new hyperclass is coming in 2 years, GTE will die, I think. And GT3 will be like in IMSA. They all go to GT3. There will not be a GTLM anymore. It's also quite expensive to run a GTE car. For the price is already almost a double. You have confidential tires. The engine is more expensive. The gearbox is more expensive. But I think the main reason why there's still GTE driving for customer teams is because you have customers who just want to drive in the highest class possible. So they don't want to drive a GT3 because it's only GT3 and there's a GTE available. So I want to run in the highest class, even if they don't have maybe the ability or the skills to drive it. They still want to do it because first of all, they have the money and they just want to spend the money.
Yeah, and that's something that I wanted to point out as well. There's quite a big difference in driver aids between a GTE and a GT3, right? Like particularly in ABS. So it is for an amateur driver, which obviously we're talking here in sports car racing, largely you're talking Pro-Am driver combination. It's a pretty big step up for an amateur to be dealing with a GTE car as opposed to a GT3. Not only does that you got less driver aids, you also got a lot more downforce, as you said, in the GTE. So suddenly it's your job to exploit all that downforce, which, to be honest, is just a lot scarier.
Yes, we did an analysis a few weeks ago regarding Spa, and the cars in Spa, so the GTE spec cars in the last 10 years, they got 10 seconds faster on a 2-minute 20, 2-minute 15 lap. So 10 seconds is a big amount, but the engine power was kept quite similar. So this improvement of 10 seconds has to come from somewhere. So this is only tires and this is aerodynamics. There's nothing else which is able to propel the car faster. So for pro drivers, this is easier to adapt because the cars are more on the edge. There's more downforce. You have to exploit the downforce because to have proper downforce, you have to go fast as well. Otherwise, it's not really useful. And this is also the tricky part for amateur drivers or bronze drivers, we call it in our series. It's the cars are more on the edge. You have to drive them more on the limit. The tires are getting better as well, but maybe also the degradation of the tires is also getting worse. You have to use the peak of the tire. You have to keep the heat into the tire. If there's a safety car or a slow zone, the tire is dropping. The bronze driver or the amateur driver has to bring the temperature back up. And with the newest spec cars from the last years, it's getting more and more difficult. So we also notice it in our team that the bronze drivers are sometimes more struggling than the years before with the car in general and to bring the car in the best optimal window to perform. The window is getting smaller, which is easy for the pro driver, or the pro drivers always like a bit rear axle loose, so they can turn more around and more control and drift a bit more through the corners. But for a bronze driver, he doesn't have the skills or the experience or the speed or the reaction time to cover this. And this is sometimes a bit the issue we have now. It's more challenging for the bronze drivers to drive the car in a for them a safe way or a competitive way. And then there's always a big difference between bronze drivers. The level is pro drivers. They're normally within a few tenths or within half a second. An amateur driver can go 1 second slower than between the other ones, or even 2 seconds, or even if it's an old guy driving, for example, it can go up to 3-4 seconds. So the slower drivers with the less experience, the less I would say the less big balls, let's say it like this, they lose a bit more performance regarding this than the guys who just, I point the car, I go on the throttle and I see what happens. You also have a lot of crazy guys. And they dive into every hole they see.
Perfect.
No, but I'm just being honest here. It's like it is at the moment, and this is it's making it quite.
Oh, I can understand. It's still scary.
Yeah, and this is you have a lot of bronze drivers, amateur drivers. They come from LMP3, LMP2, so they have to use downforce there because the prototype cars in very tight corners, they have no mechanical grip. It's mainly the high downforce side and the top speed they have. So they have to get used to downforce. But these drivers, they come now to GTE driving because maybe they won everything already in the prototype car class. They are used to the aerodynamics and they know how to use the aerodynamics. So this is a trend we see like in the last year, 2 years, quite a lot. So if the new class, the LMDH hyperclass is coming and there's only GT3 and then the LMDH and you have customers in the LMDH, which is hybrid, 4-wheel driven, more aerodynamics, different brakes, ceramic brakes maybe, or carbon brakes. It's going to be quite a challenge, I think. So this is something in the future. I have no idea how it's going to go.
So I want to touch on what you were talking about there with the difference on Pro and AM. One of the questions I had thought about before we started recording was, what's your philosophy as far as setting up the car? I mean, obviously the Pro is always going to be extract more out of the car. So you need to be able to exploit everything the car's got, but at the same time, you may well be able to give the Pro the car they want. And it may be very difficult for the amateur then to drive the car at all. So how do you guys normally approach tuning a car? How do you sort of decide to bias it between what the pro wants and what the amateur needs?
Yeah, so I have 2 different bronze drivers now, and I drive with them already for 2 years. I've with another guy already for 4 years. So I know a bit what they want, what they prefer, which is no oversteer. The pro driver always likes a bit of oversteer, but I can use 2 very experienced professional pro drivers, and they know their bronze driver, and they know this is good for them. So this is also the difference. You cannot put every pro driver with a bronze driver because they cannot translate their experience or their technique or their feedback regarding the car or the track or the weather conditions or even the changing conditions because there's more rubber coming down on the track with the bronze driver. So not every pro driver can work in a customer series like we do, for example. It's a big difference. And what I always do, like the last races, it's always every session I start with the pro driver. I check the condition of the car. I check the track conditions. I do a few runs just to check if the setup is okay, and then we improve every time the setup a tiny bit. And at the point he says, car is good, it's good to drive, it's stable, the rear is stable, this is for me very important. Then the bronze driver goes in and he does laps to get used to the car, the brakes, the track, the traffic. And then we have the 3rd driver, it's normally a pro AM, it's silver driver for us. He's just finishing the stint to make sure we can do a full stint on the tires. This is normally always the format I use. But for this year, the car we have now, it's a very improved aerodynamics. So the GTE Porsche RSR 2019 has a very strong front axle. So the rear axle has always been quite challenging. And so we always try to focus on the rear axle to make the rear axle stable for the bronze driver, the amateur driver. Because on the high speed part where you gain the time, this is where we need to have the bronze driver working. And also the bronze driver is for me more important than the pro driver. The bronze driver is always driving much longer. So in a 6-hour race, the bronze driver has to drive minimum 1 hour 45 minutes, and the pro driver only has to drive 45 minutes. So the bronze driver is doing 2 stints and the pro driver is doing 1 stint, maybe maximum 2. So in the end, the bronze driver, if we can gain the bronze time, if we can bring the bronze driver up to speed and he's gaining half a second or even 1 second a lap, it's much more than we can gain with the pro driver. Maybe we can gain maximum half a second a lap. But in the end, the bronze driver, he's the one driving the longest in the beginning of the race. And normally the car is always quite good for the bronze driver and for the pro driver in my case. But is the biggest difference is they have to drive the longest. They have to feel comfortable with the car. And in the end, they're the customers. So they pay for the car and the race and the thing. So they also have to be happy. So for me, they have to be comfortable and they have to be happy in the end.
So essentially, just to recap and sort of tighten that up, your philosophy there is to establish a setup that the bronze driver is comfortable with and can go fast with, and then the pro driver will adapt to that setup, even if it's not quite an optimal setup for the pro driver.
Yes. If you go for a pro driver in quali, you increase the rake, you go up with the wing, you make it lower on tire pressures. But to drive like this for 1 hour, it's also not possible. And for the pro drivers, we always give them a bit less tire pressure, or if they have a bit too much understeer, then we change the front tire pressures, for example, to make it a bit more competitive. But in the end, at the end of the race, the track is getting rubbered in, so it's also getting a bit faster. And the pro drivers, they can change or adapt their technique quite a lot. So they can, if they want a bit more rotation, then they trail brake more longer into the turn. Then the rear axle is more or less, the chances of the rear axle stepping out is a bit higher. So then they can rotate the car a bit more. They also have a better feel for TC settings, brake bias, traffic-wise. So in the end, they get paid for this, and they have to drive with the car we give them. But they can more drive, if they have an issue like regarding understeer, oversteer, or aero wash, they can drive around the problem much more easy than a bronze driver. So the bronze driver is always the best car for them. And the pro driver can make the car also competitive. For me, in any case, every time, the pro driver was able to be very fast as well with the setup of the bronze driver.
In terms of making setup changes to a factory-built race car like this, what are your tuning options available, and what would you be looking to change during a race weekend to adapt the car to suit the driver?
We have a lot of things to change. We can, even from the smallest things, we can put more weight in the front, we can put more weight in the cockpit, we can put more weight on the subframe, on the axles. We can play with ride heights, front left, front right, rear right. We can play with the splitter to make it straight. We can, in the past race cars, in the past years, we can make it nose up, even nose down. We have, of course, camber, toe, wing settings, brake blanking. It's also very important to make sure the brakes are always not too cold, not too hot. Too hot, they will wear out quite a lot. When it's too cold, they can break or they can just not perform properly. There's even engine blanking to make sure we have the most optimal temperature for the engine. But there's a lot of things to do. You can also even change, play with the tire pressures. With the tire pressure, just you lower them 0.1 bar, then the car feels completely different. So then the tires are maybe proper in the window. You can even play with a soft tire on the front, medium tires on the rear, soft tires on the right side, medium tires on the left side. You can do any combination you want. You can play also with the shift lights if the acceleration is not properly or they're hitting the ref limiter too much. You can play with the shift lights. There's a lot of things. We also have a lot of sensors in the car. We also have damper forces, so we also can see how the aerodynamics affecting. We also even have a splitter, the deformation sensor, so we know if the splitter is working, yes or no. If the splitter moving, then it means we're sucking down the car in the front. Is it not moving, and we know it's not really helping. There's also, of course, the damping, the spring rates, and the bump stop gaps is also quite important tuning part we can use to make sure the front and the rear axle are connected when you go braking or on the high downforce parts. Did I forget something?
What about kinematic options? I think maybe the RSI has kinematic options to put the suspension arms in different positions.
Yes, we also have this at the moment. The good thing is this car, it's only available for customers after 1 year, driven by the factory teams. So they always, in 1 year, they test also, they improve hardware, they improve software, they improve certain parts of the car as well. It's a different design as well. And we can change the kinematics as well. I believe we're not really allowed to do a lot of things on this. We cannot do it without notifying them. But you can change the roll center. You can move the rear roll center, for example, more up or down. You can increase the anti-dive, the anti-squat, this kind of stuff you can all change. And the previous question, I forgot the diff. There's also still a diff with the preload, the ramp angles for throttle, braking, off throttle, coasting. So this is also a quite big part. But the kinematics, yes, we can change them. To be honest, I didn't do anything yet about this year because for me it was always quite good because for this car, the front aero is very good if it's working. So this is mainly the thing we have to make sure it's working. And kinematics at the moment, maybe we have to change them by the end of the year if we go to different tracks. But this is depending on the factory support, if they have experience about this, yes or no. Because we don't have the possibility or the capabilities to put a car on a KNC machine and see what's the best kinematics or on a 7-post rig, what's the best the optimal damping clickings or a spring stiffness. So this is a bit the lack we have of information and experience and possibilities regarding this.
Could you just, going back a little bit there, describe exactly what you mean by a KNC rig?
Yeah, so KNC rig, you can put a car on it. So you put a car on, I think it's like 4 posts. You attach sensors to the chassis, to the tires, to the rims, and then you move the car around. You bounce it up, you bounce it down, you bounce it to the left, right, you roll it, you pitch it, and then you see how the car is reacting, how the tires are moving regarding to the rim, to the chassis. You can analyze the entire vehicle behavior of the car. You can also simulate downforce, for example, by clamping the chassis on the bottom. And you can push it down to see is most of the energy of the downforce, is it going to the damping, into the springs, into the maybe even bending of the chassis. It's also even possible if the chassis was not designed well, how much energy is going to the tires. For me, the only big disadvantage is the tires are cold, which is a big difference on the racetrack. Hot tires are completely different. You can even warm them up, but it's a different world if you're really driving. Your tires are rotating and driving. And then wind coming from the front, the rear, the back, the side, the top. So it's quite a big difference. But a KNC rig it's interesting, but you need to know how to use it and how to use the data and analyze the data as well.
So it's really about, obviously every suspension geometry, when you're doing a basic analysis, you're kind of assuming everything's rigid, but the KNC rig is sort of allowing you to see how everything, all the angles and arcs and everything's really moving when it's actually loaded up, which can be quite different, but it's obviously a lot more of a complicated sort of analysis to do.
Yes, it's KNC is for kinematics and compliance. So you want to know how is the car moving if I push it down with, let's say, 500 kilograms of downforce, or when you take a corner with a 2 or 3G, how is the car moving? So where is the movement going to? Where's the energy going to? Even the steering rack, if you start steering the car, maybe the steering rack is bending as well, and then you have no idea. And I can tell you if you're on the racetrack and the car is not doing what you expect it to do, and you suspect there's something bending in the car, good luck finding it out on the track. It's not easy.
Do you rely? You've said you sort of maybe aren't using all of those tuning tools that are available at this point. But with such a broad range of potential adjustments, I can only imagine it would be very easy to go in the wrong direction and end up moving away from the sort of performance envelope you're aiming for. Do you rely on any simulation tools to sort of help you understand what sort of setup is going to be suitable for a particular track?
No, the simulation for us. We get a pre-event always from the manufacturer, and he gives us sensitivities. So if you change the aerodynamics, how much is the top speed going to be affected? Which corner is very important? In which corner can you gain the most performance? What's the effect of the weight? So for 10 kilograms, for example, you lose or you win 1/10 of a second. They do some simulations also for us, the tire supplier. They also do some simulations to see where's the energy of the car going to. For example, I now came from Monza, which is more or less right-hand side turns all the time, right side. So it makes sense to put a bit more time and performance on the left side of the car. So increasing the cambers, making sure the tire pressure is not getting too high, but also not too low, because then you get too much movement. So this is small bits of simulation. But we also have Spec Finder from Multimatic, which is it's not I would call it like a real, but also simulation tool to see what damper clicks are going to affect what on the damping, like low speed, high speed, blow off, rebound, bump, all this kind of stuff.
We've talked here about all the different things you can touch. What do you think the most 2 or 3 common tools are that you're using when you're chasing like a balance issue? Like, are we talking, is that you more often to use like maybe a small camber change, a tire pressure change? Like, what are your biggest tools that you make use of? I
would say like ride height, just to make sure the rake and the platform, because like I said, it's an aerodynamic. It's quite an aerodynamic car. Then if you talk about aerodynamics, you talk about the platform. So front ride height, splitter, rear ride height, to make sure this is in the window. Because if you're not in the window, then you can do whatever you want, camber, stow, everything, bump stop caps. If you're not in the window of the aerodynamics, it's not making any difference. So this is always the first point: is keep the platform in general, like spring stiffness you keep. And the first thing we always try is what's the platform? How do we get into the window of the aerodynamics? And then if we know, okay, we have the top speed, we have the rake we want, we have the cornering speed, and then you try to, if the baseline is there, then you need to find out what's the tires you want to use, soft or medium, or the hard tire. And then you start fine tuning with a bump stop cap or a damper clicking there, or again, maybe with 1 millimeter ride height, just changing the conditions if it's getting more hot. So for me, I would say the ride heights are the first thing to make sure the aerodynamics is in the window.
You've just mentioned bump stops there and bump stop gaps, and that goes hand in hand with your aerodynamics on the platform, as you've mentioned there. So you're using those bump stops to help control the ride height and the high speed sections of a track where that downforce is going to essentially try and push the car into the racetrack.
Yes, bump stops are quite tricky sometimes. But as an example, in Eau Rouge, there's a big like compression on the bottom, and then you go up. It's the same as in Portimao, the last turn. And if you go in a very high compression, you need to make sure the front and the rear axle are synced. So if the front axle is hitting the bump stop, for example, faster than the rear one, then you create a lot of understeer. But if the rear is hitting the bump stop first, then you create maybe a lot of oversteer. So you have to make sure that in braking or in high speed cornering, that the car is synced front axle to make it as neutral as possible. So to make sure the drivers, they're not scared when suddenly the balance change is shifting in high speed, because this is something you definitely want to avoid. Is going from entry understeer to mid corner oversteer and back to understeer on the exit. You don't want to have all the balance shifting in one corner. You want to make it as predictable, as linear, as stable as possible, and just to make sure the driver feels good and can go on the throttle as early as possible, but not fighting like hell to be able to make the corner, but this lap by lap, because it's still endurance racing. If it's a sprint race for 2 hours, then the drivers can survive. But if you do a 6-hour race or a 12 or a 24-hour race, the drivers have to drive hour by hour by hour. So they also have to be sure like they can do it physically. So remember a few years ago, there was the Bathurst race with Matt Campbell driving, and he was in the cockpit 40 degrees. Outside it was 40, 50 degrees. Track temp was out of the roof. He was fighting like hell, but he was also completely dead afterwards. So it's a fine line, but it's also the decision by the driver itself. But you need to make sure the car is predictable, because otherwise it's also for the bronze drivers, it has to be predictable. And I would say in the most linear way as possible, so they know what to expect. Especially if you lose the downforce on this type of cars, then the balance is completely different, completely gone, and then it's a struggle to to do what you want to do, is to make the corners fast as possible and brake at the same point.
When you're talking about making ride height changes to affect your aerodynamic balance, what sort of magnitude are we talking here? If you've got like maybe a moderate or a small to moderate balance shift you need to make, if you were going to make a change on the front axle, for example, what sort of order of magnitude are we talking about in terms of making a ride height change?
Talking about 1 millimeters, like 1-2 millimeters. That's the magnitude. So it's quite small. Like with the previous generation cars, it was probably about 2, 3, 4 millimeters. The rake was also much higher, but now for example, if the rake was 30 millimeters last year, maybe now the rake is 15, 60 millimeters. So it's half of the rake. So also 4 millimeters last year to make a shift is now maybe going to 2 millimeters. So I would talk about half a millimeters. I would like to do half a millimeter as well, but we don't have the right shims to do this. So it's millimeters. I complained already to my mechanics, but I don't get anything else.
In terms of the data system you've got on the car and sensors, what have you got there and what are you looking at?
We have a Cosworth system, so we use Pi Toolset, Pi Toolbox, and the Porsche support people, they also use Bosch. But we have a tool set, so it's a software setup for the car. So it's telling you what shift lights do we have, what's the fuel alarm, what's the calibration of all the sensors, what's the offset of the sensors, what's the reference lap time, and this is every time flashed every race, or if we change something on the data logger and on the steering wheel as well, because the steering wheel is also integrated in the whole system now, so it has a very complex program and possibilities. And looking into the sensors, we have a lot of sensors. We have tens of sensors on the engine, gearbox, temperature, all this kind of stuff. But this is mainly for the performance side of Porsche, who are responsible for the engine and the gearbox. But we look mainly to the ride heights. We look mainly tire pressure, tire temperature to see we're not overusing the tires. We also have, of course, the speed, the GPS location, the throttle, braking, damper pods to see what's the movement of the car compared to the ride heights to see how much is the tire moving. In the IMSA, we also have a track temperature sensor, which is also interesting to use because then you get a live update about the condition on track. But then the amount of sensors we have, for me, I think it's not too much, but what you can do with all the sensor data. So, for example, with the damper pods, the damper potential meters, you get the travel of the dampers, but you can make it a speed and acceleration to see, do we have vibrations on the damping or we have an issue, the damper is breaking down. With the throttle and the braking, okay, a lot of people, they just think you just see the braking or the throttle, but you can also see, is he overlapping? Is he fuel saving or not? Is he aggressive? Is the tire at the end of his lifetime because he's going a bit more gentle on the brakes, a bit more gentle on the throttle? This is the data we use. They're more called the KPI. So team is also aware of this. It's just to make as much use of the data as possible. But also, as a side note, we don't want to make it too complicated because I'm in a customer racing team. With the pro drivers, yes, but talking about damper speed, accelerations, trail braking, off brake speed, all this kind of stuff you can calculate. You need to be careful with the bronze driver because you don't want to overload them, because if they start thinking too much, then it's never a good thing. So,
when you talked about one of the sensors you listed, there was ride height. Is this using like a laser ride height sensor that's built into the floor?
Yeah, we have 4 of them. The main challenge with the ride height sensor is, where do you calibrate it to? So you calibrate normally to the floor, but with our car now, it's quite of a tricky one. So we have also a skid block on the bottom of the car, and this is now used as a reference plane, but the skid block is getting used, of course. So then the calibration, the gain, we keep the gain for the entire year normally, but then the offset is always a bit different because we still have mechanics measuring the ride height. They lay underneath the car, they measure the ride height, but maybe in the morning they measure 45 millimeters, but in the afternoon they maybe measure 46 or 47 because the light is different, or the ruler is a bit different, or they look at it differently. So it's still quite difficult or sensitive to get it's not like an LMP car. So that's why I'm not allowed to use 0.5 millimeter ride height shims, because the tolerance of the ruler, for example, it's only 1 millimeter. So
do you think during a race weekend, what would the most common senses you've been paying attention to, particularly when looking at maybe driver performance? Like, I assume a lot of your time is probably taken up trying to help your amateur drivers, get a bit closer to the pros. So as far as driver inputs, what are the main things that you tend to make use of, and what are the sort of main driving differences you tend to see between your pros and your amateurs?
Yeah, so when the car goes out of the pit lane, the first sensors we always check is ride height in the pit lane. So we have an idea of what's the current rake ride height, and also if it's matching the values we have on the setup pad. And then also what we use during the run, it's the the brake temperature to make sure the brakes are also okay and in the window. But then regarding the bronze drivers and the pro drivers, it's of course the brake, throttle, steering, speed, and the gears to see how are they braking. Are they braking early, later? Are they braking late because they think I have to brake late, so to gain time, but then they get stuck into the corner. If you have a left-right hander or two corners in a row, they always go for the first corner, but the second corner has the exit, so you always have to focus on the second corner. Or they go in between corners, they go full throttle because they think, oh, I'm going too slow, I have to pick up the pace. They go full throttle, then they create a lot of understeer in the second corner, and then the exit is very, very poor. So I would just mainly say about it's where they brake, how they do go off the brakes, and then the timing wise, when do they start steering, when do they start steering and going on the throttle. It's this line of timing. It's very, on a video you cannot see this most of the time, but it's just like it can be like 5 meters later steering and only like 5 degrees just to rotate the car a tiny bit more to have a better exit. And this is the feel the pro drivers have easier, or they also try it in a simulator, for example. But it is something we try to teach the bronze drivers as well. But it's just mainly the driver sensor, so steering, brake, throttle, speed. And this is also for them the most easy to understand, because this is they are responsible for this, so they have an effect on this. So if they want to go faster, they go more on the throttle. They know, okay, I have to go on throttle. But if I go on throttle, but I've understeer like hell, then the TC is cutting the engine. So then it doesn't make sense. So I have to rotate the car first and then go on throttle. So it's just trying to translate the performance of the pro drivers to the bronze driver. But just for this, like my bronze drivers, they're only interested in this. If I talk to them about the bump stop gaps and synchronizing the front rear axle and the brake temperature, then they're lost, and it's not their job.
It really sounds like this car's got an enormous number of setup options, but also a really complicated car. If you could have one extra tool or change one thing about the car in order to make your job as an engineer easier, what do you have anything in mind what that would be?
An extra tool. At this moment, I would like to have a bit more engine power. Nothing I can do about this. No, the thing is this.
Who wouldn't want more power?
No, this car it's designed for a very good aero. So for me personally, if you're alone on track in a quali lap, it's a good car because there's nobody in front, nobody behind. But the problem is if you have an aero car, if the tires are getting worse and worse through the stint, the performance is also going down. But if you have a good engine and a top speed, even with tires which are completely worn out, you still have the top speed. And on the straights is where you overtake the other cars. So for example, last year in Le Mans, the Aston Martin, we were behind the Aston Martin. We were trying to get a slipstream. We were like 1 meter behind, but we cannot even hold the slipstream. So the Aston Martin just pulls away, and then it's an easy pull away, because if you're a pro driver or a bronze driver, if you have the top speed, you go on throttle, you're gone. But then it's a very skilled car, the Porsche, because it's a very good car, but it's very focused on cornering, and the tires are a big impact on this.
What's the one thing you think about this? The one thing you're always complaining about on the car. I think there's one thing that they should fix on this car.
For me, it's now the engine power, because the Racing Monza was a disaster. No, but because they focused a lot on the front aero, that the rear is sometimes, it's very tricky. The main focus is always the rear axle to make sure the rear axle is stable. And when you start sliding with the rear axle, the tires heat up, the tires worn out much faster, and then it's getting worse. So it's I would say, like, what I really like is, for example, on the Ferrari or even on the Aston Martin or the Ford, they have a very good balance front rear. Like the aero balance is very, very good. The distribution is very good, and it's very easy to drive. It's very easy on tires, and it's very easy to drive also for a bronze driver. The Aston Martin as well. It has a good aero, but when you go out of the corner, it just squats down and the acceleration is there. It's just a very safe car for an amateur driver, and this is what I like as well.
I guess with what we've talked about so far, and there has been a bunch, is there anything you feel like we've overlooked that you think's really important to getting the lap performance out of the car?
Part for us in any race, so 6, 12 or 24-hour race, it's strategy, and because we always have 3 drivers in the car, and they all 3 have different driving times. So the bronze driver is, for example, in a 6-hour race, it's 1 hour 45. The silver is 1 hour 45. The gold is 45 minutes. So you have to adapt to, okay, how long does the bronze driver drive? Because we don't want to make him drive too much, because then we lose maybe a bit of performance on track. But you want to make sure he's driving the first. So if there's a safety car or you're in the lead lap, then you come back together. But for example, in an 8-hour race for us, the bronze driver needs to drive 2 hours 20, which means it's 2 stints plus 20 minutes. So then he's actually need to drive 3 laps, 3 stints, which is 3 hours. So for us, it's not only about performance of the car, but it's also performance regarding strategy-wise, to make sure you exploit everything as much as possible. You want to make sure that the bronze driver is always at the beginning of the race with good tires, and trying to make sure he's following the pack or even fighting with the front runners. But for us, it's also strategy-wise. It's quite a big step. Like in Monza, my car had quite a big top speed deficit, and just only with the strategy and a safety car, luck for a safety car, we got P5, and I think we were more or less the slowest car on track. So from, I think, 14, 15 cars. So this is also purely strategy-wise. So it's not only about setup, but also making sure the drivers are well rested, and putting the correct driver at the correct time with the correct tires. Because if you put the pro driver, but the tire pressure is too low or too high, for a 24-hour race, he stays 2 hours on the same tires, then good luck, have fun, and just watch the competition drive away.
So it sounds like you've got a lot on your plate at the moment. You're wearing quite a few hats across quite a few different race series. What do you think is in the future for you? Are you pretty happy with what you're doing at the moment? Do you see yourself maybe moving into a bit of a different role, or what do you see in your career going forward from here?
The big thing is, I always told to everybody, if I have a family, I would not do racing because I'm going too much. The good thing is, I met my girlfriend while I was doing racing, so she's only used to me doing racing. So she told me just to keep doing it. Because for me, the good thing is when I'm home. Okay, I have to work from home, but I don't have to go to the office or the workshop every day. But then I travel to races. But this year is completely different because we do 3 race series and then testing in between, and 5 cars in Le Mans. So it's getting a bit too busy probably. But this is the first year I'm full-time race engineer. We had different tires in the LMS, so different Goodyear tires, new tires, a completely new car, which is very complicated and much more complicated than the previous cars. So I'm just trying to get up to speed and try to just do the best I can. And until this point, every race, the car was, from my job, so balance-wise, setup-wise, preparation, the car was always in the window. It was competitive. But then due to external factors, we got hit a few times by other cars. We had a drive shaft issue a few races ago. So it's always something. It's not have been the best year. But I would say at the moment I like it. I still learn a lot. This is for me the most important thing. I still learn. I'm 31 years old, so I still have a lot of things to learn, of course. At the moment, LMDH is also coming around the corner in 1-2 years, and Proton, at the moment, they want to participate in this as well, both in Europe as in the IMSA probably. So I want to see where it goes and see which role. But I'm now the race engineer, so I don't have the ambition to be technical director or team manager or starting my own team. I don't have the need for this. So, but let's see what's coming on. So don't know at this moment. If you ask me honestly, what would you do if you don't do racing? I have no idea. And this, my girlfriend also knows. I have no idea.
Stick to racing for the time being, then could definitely be in worse positions. Given what you've learned and your path to get where you are right now, if there's someone listening to this podcast who aspires to be a race engineer doing what you're doing, what advice would you give them to fast track their sort of direction?
Yeah, the thing is, I would say if you can work in racing, it's always interesting, but then try to listen and just look around and see what everybody's doing and just take notes and try to take in all the information. But always try to be open as well for different opinions. So there's always old school people racing. They use a paper and pen, or they don't use simulation, or they stick to certain protocols and procedures, but always try to do something different or innovate or try to do something new. So don't always copy what other people are doing, but I believe every engineer has his own style of running a team, communicating with the mechanics, communicating with the drivers. Everybody has his own style, and this is also for me. This year, I'm developing my style, how to do it, and just always be respectful for the other people and respect their opinions as well. But just always try to develop your own style. This is quite important this year, and even if it's mechanics or your tire guy or a driver change helper guy or the guy who's changing the water bottle, it's a whole team.
Solid advice.
If people want to follow your exciting life traveling around the world doing all of these exotic races, how can they do this on the social media?
Yeah, I have an Instagram, but the last picture is from, I think, August 2019. The reason I have this Instagram is because I took pictures for
quite up to date.
Yeah, so you go for it.
I went to every time I went to a racetrack or a different location for work, I took a picture and I put it there so my mom would be able to see and know where I was, because she never know where I was. But after this, I stopped doing this because I went all the time to the same racing tracks. And as an engineer, everybody thinks you see the entire world and you have a lot of free time when you're traveling, but you see the airport, the plane, the hotel, and the racetrack. That's all you see. So if you go to the racetrack 3 times a year or 3 years in a row, the pictures are always the same. So I just stopped taking pictures.
Maybe not always as glamorous as everyone thinks.
Definitely not. No. It's long days. Most of the time it's good food, but it's a lot of traveling. But I still use my Instagram to follow other people, racing people, my drivers, technology. I follow this. So if they want to contact, they can contact me on Instagram. It's p.arne. This is my Instagram account.
Hey Arne, thanks very much for your time tonight, mate. It was a really interesting chat.
Thanks a lot for your time, Arne.
Thank you very much for having me.
All right, that concludes our interview. And before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 $75 off the purchase of your first course. You'll find our full course list at hpaacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our Gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a Gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpaacademy.com/courses.